In this video, we're going to look at how you can estimate the distance travelled by using a velocity time graph. Now, this is not a distance time graph, remember, it's a velocity time graph. So we can't simply read off how far someone has travelled by looking to one of the axes. If you remember our previous video, we saw that the distance travelled was the area under the graph. And we're going to see that that's still true even when we've got a curved graph like this. So, what is this question about? Well, a go-kart is tested by accelerating up to its top speed and then braking to a stop. Let's start with the first question. How long does the go-kart take to reach the top speed? The highest speed reached here is 10 meters per second. And that happens 4 seconds after the kart starts accelerating. So the answer is 4 seconds. Next, it says estimate using 2 strips of equal width the distance travelled by the go-kart by the time it reaches its top speed. So what we need to do here is work out a distance from the previous video. That means we need to find the area under the graph. And what time period are we looking at? Well, it's only by the time it reaches its top speed, which happens at 4 seconds. So it reaches its top speed of 10 meters per second after 4 seconds. That means what I'm going to do is draw a line from 4 seconds up like this. And we need to find the area of this bit here. Now, this is not a nice shape to work with, which is why the question says estimate. What we're going to do is split this up into strips, and the question tells us to use 2 strips of equal width. How do we do that? Well, this here is 4 wide. To split it into 2 equal strips, we need to split it down the middle like this. So now I've got 2 strips, each of which are 2 wide. This still doesn't massively help us because this is not an easy shape to work out the area of, and neither is this. Here's what I'm going to do. I'm going to join this point on the graph with this point on the graph using a ruler. And then I'm going to join this point on the graph to this point on the graph using a ruler. So I end up with this. Now, I've got a triangle and a trapezium, and I know how to work out the area of each of those. So I can work out those areas, and that will give me an estimate of the distance travelled. Let's start with the area of the triangle. That is 2 times 8 divided by 2. Base times height divided by 2. So 2 times 8 divided by 2 is just 8, and the units for the distance are going to be meters in this case. So that's a distance of 8 meters travelled in 2 seconds. Now, for the area of the trapezium, you can either use the formula or you can split the trapezium up into a rectangle and a triangle. I'm going to split it up like this. This rectangle has an area of 2 times 8, which is 16, so that's 16 meters. Now this triangle has a base of 2, that's the difference between these, and it also has a height of 2, that's the difference between these. So the area of the triangle is base times height divided by 2, so that's 2 times 2 divided by 2, and that just works out to 2 meters. So the distance travelled by the time this go-kart reaches its top speed is 8 meters plus 16 meters plus 2 meters. Well, that's just an estimate, but what we get is a total of 26 meters. Now, this is actually an underestimate. The true distance travelled is going to be a little bit higher. What we've worked out is an underestimate because you can see there are parts of the area that we haven't calculated. All of this is part of the area under the graph, and so is this little bit here, but we did not include those parts. That's why we have an underestimate. Finally, we have to estimate the distance travelled by the go-kart after it starts to brake. Now notice it starts braking after it reaches its top speed, so after 4 seconds. That means we want to find the area here, all of this part of the graph. Now we have a choice. It doesn't tell us how many strips to use, so we could use just one strip that is this wide. We could find the area of this triangle and use it as an estimate of the answer. Now, hopefully you can see that this is going to be quite an underestimate because we're missing out a lot of area here. Now, we might be okay with that, but let's say we wanted to be a bit more accurate. What could we do? Well, we could split this into strips. So instead of having just one strip to give us this triangle, we could have 2 strips. Let's see what that would look like. First, I'm going to split this distance here into 2 equal strips, and that gives me a straight line like this. Now I'm going to join this point to this point, and then I'm going to join this point to this point. Now, hopefully you can see that that gives us a much better estimate. We've got a much tinier amount of missing area. So we're still going to have an underestimate, but it will be closer to the correct area. If we wanted to be even more accurate, we could split this up into more strips. So instead of 2 strips, we could do 3 strips, 4 strips, 5 strips, as many as we wanted. Anyway, let's stick with these 2 strips. Pause the video and see if you can work out the distance travelled by the go-kart after it starts to brake, so between 4 and 6 seconds. Here's what you should have found. The area of this trapezium is 9, so that corresponds to a distance of 9 meters. And the area of this triangle is 4. That corresponds to a distance travelled of 4 meters. So the go-kart travels an additional 13 meters, 9 plus 4, 13 meters after it starts to brake. Let's summarize the big idea from this video. You can use a velocity time graph to work out the distance travelled by finding the area under the graph between 2 moments in time. Now, if you've got a curved graph and it's difficult to find an exact area, you can estimate the area by splitting it up into strips and just working out the areas of triangles and trapeziums. Depending on the shape of the graph, you might end up with an underestimate or an overestimate. And in general, the more strips you use, the more accurate your estimates become. Normally, you won't have to decide how many strips to use for yourself. The question in your exercise book or your exam paper will tell you how many strips to use.